Good morning, everybody. Thank you for joining this webinar. Focus of this webinar is taking a look at how we can simplify application security with VMware AppDefense. Before I get started, I'll do a quick introduction on my side. You can see my name there on the slide. It is Josh Cooling. I'm a networking and security specialist, systems engineer working at VMware. So focus, as I said, of this session is going to be AppDefense. AppDefense is one of the technologies that fits within the VMware networking and security portfolio. In that portfolio, we have technologies that you may be familiar with, such as NSX, such as VMware SD-WAN by VeloCloud and Hybrid Connect, amongst other technologies. AppDefense is our endpoint or application security technology, which is extending our least privileged security model from the network space, which is achieved through NSX, into the application space. So achieving a least privilege application execution security model. So with that, I'm going to make a start. So the focus of AppDefense really is around the security conundrum that we see here, whereby enterprises have two competing priorities. The first of those competing priorities is to give people the freedom to act. So from a developer's perspective, it's allowing developers to develop new lines of business, new business services, new applications. It's enabling enterprise IT to ultimately do what it is they need to do to meet the demands of the business. But then the other competing priority is to balance this freedom of act with mitigating risk. So not only can we give people the freedom to do what it is they need to do, but we also need to mitigate the risk associated with giving that freedom to do what it is the business needs to do. So we see these two competing priorities within every enterprise IT organization that we meet with. And ultimately what needs to happen is a simpler way to secure applications that, one, simplifies the approach to reducing the attack surface, so minimizing the number of approaches that an attacker could leverage to compromise your application, whilst achieving the second outcome that we can see here, which is enhancing our ability to detect and ultimately respond to attacks. So reducing the attack surface whilst then also detect and respond to those attacks as well. So this is two of the key priorities that we need to follow when securing our applications. So AppDefense itself is shifting the application security model. If we look at the traditional endpoint security or application security model, it's a model that focuses on chasing bad. So many application security technologies use a set of signatures that they look for to protect against. So we're chasing what we know to be bad. With AppDefense, we're changing this security model to a model whereby we're ensuring a good state. So rather than chasing bad, what we actually do is look at how things should run, how should our applications behave, and that's a far more well-defined scope. So there should be a set number of behaviors that we would expect to see, and our application should operate within those parameters. And what we're doing with AppDefense is we're ensuring that good runtime model. So rather than chasing bad behavior, we're looking at what should be good, and we're protecting that good state. And I think it's important to really contextualize where these technologies sit within the broader security ecosystem. So clearly there are many security technologies from many vendors, but it's important to actually understand where these technologies fit within the layers of enterprise IT security. So what we can see here is a pyramid of cloud workload protection technologies. The bottom of this pyramid is what Gartner perceives as being foundational. Moving up the pyramid, we see technologies that are perceived as being less critical. Clearly, all of these technologies underpin enterprise IT security, but it's understanding which of these really we should be focusing on in the first instance and prioritizing highest. So if we look at the very bottom of this pyramid, and just beneath the pyramid, we have restricted physical and logical perimeter access. So clearly we need to secure the perimeter, and that doesn't change. We then have a layer of operational hygiene. So what are the things that we should be doing within our operational teams to drive positive IT security outcomes? Then we have the base of the pyramid, which includes things such as hardening, configuration, and vulnerability management. So these are things that we can do to ensure that our systems are configured in line with best practice, to make sure that we've hardened our systems. From a VMware perspective, we have things such as the VMware validated designs. We have things like VMware Cloud Foundation that take those validated designs and actually deliver something that's self-deploying, lifecycle managed. So VMware can certainly help you with that foundational principle of cloud workload protection. Layered across the top of that, we then have network firewalling, segmentation, and visibility. So from a VMware perspective, we have technologies such as VMware NSX, vRealize Network Insight that can help achieve network segmentation and give you the visibility to drive network segmentation policy. Layered across the top of that is where we then start to see AppDefense and the AppDefense capabilities coming into this pyramid. So AppDefense provides us with things such as system integrity monitoring and management, application control whitelisting, and it also encompasses exploit prevention and memory protection technologies. So I think it's just important to understand where AppDefense fits into this model. So NSX provides the network segmentation, and AppDefense provides the 3 layers of protection across the top of network segmentation. And if this concept of zero trust or least privilege is a new term to you, ultimately it's simple. So the zero trust model was originally put forward by John Kindervag while he was working at Forrester, and effectively it's the ultimate whitelist model. It stipulates that all communication within an environment should be blocked by default, and only the communications that must be allowed in order for an application to function should be opened up. And it's widely held that this is ultimately the most effective way to secure applications and data. So using technologies like NSX, we can achieve this least privilege zero trust model at a network level. And then layering on technologies like AppDefense, we can extend this least privilege model to the application itself. So we have varying layers to this zero trust model from a VMware perspective. So that was a few minutes just talking about where AppDefense fits into the security model. And now I want to step into AppDefense specifically and talk about how it achieves this least privilege model at an application layer. And really, there's 3 key tenets to how AppDefense functions. Really, what we're doing is we're leveraging our position within the hypervisor to start to build security controls that are intrinsic. So we have security controls within the VMware hypervisor that aren't bolted on. They're part of the native hypervisor. And really, this presents us a series of benefits. The first is, in context of the application, running within the hypervisor, we understand what was provisioned. So when a workload was provisioned, we see what was provisioned, and we have an understanding of what was running at that point in time. What we then have is the visibility into what's running at any point in time. So maybe the application has deviated a little bit from what was provisioned in the first instance. Given we run in the hypervisor, we actually see that current runtime state. So we understand at any point in time how that application is behaving. The second core tenet to leveraging the hypervisor is this concept of isolation. So the security controls that we're providing and we're embedding within the hypervisor are inherently isolated from what it is they're protecting. So if we're protecting a specific endpoint and that endpoint is compromised, because our security controls are running in an isolated portion of the hypervisor, they're effectively outside the trust domain of that endpoint, what it is it's protecting. So if that endpoint is compromised for whatever reason, we can ensure that our security controls are still running and are unaffected by that compromise. The third part to running in the hypervisor is the architecture is inherently software-based. We can integrate with provisioning systems, so we can achieve a high degree of automation. So this least privilege application security runtime is something that can also be highly automated over time. AppDefense itself functions in two parts. We have the first part, which is the learning phase. So when you first deploy AppDefense, we'll deploy AppDefense in this learning phase, and we'll start to gain this view on what's going on inside your environment. Once we've gone through this learning phase, we then shift AppDefense into a protect mode. So once we've built the visibility and we understand what known good should be, we can then protect that known good state. We can detect deviations from that known good state. And when we spot those deviations, we can then think about how do we want to respond to those deviations. Do we want to just alert, or do we want to prevent those deviations from taking place? Drilling into each of these phases in a bit more detail, the learn phase incorporates our intended state engine. That connects to vCenter. It also connects to each individual ESXi host. What we're able to do through this learn phase is through our connections with vCenter and with your ESXi infrastructure, we can start to understand what's provisioned, how what's provisioned behaves, and its interdependencies on other components within your environment. We have support for not just commodity off-the-shelf software, but we also support any bespoke applications that you may have developed in-house. We can integrate with your provisioning systems to also automate the evolution of this understanding that we're building. So if you're provisioning and deploying new applications using a provisioning system, we can hook into that provisioning system to update and to learn new things about application behavior and the intended application state. We also apply machine learning to all of the learnings that we gain when we're running in this learn phase. So the AppDefense system will leverage a SaaS component, and it's in that SaaS component that we are applying this machine learning. So we can feed back to you whether or not this behavior should be trusted, whether or not this behavior or this application is from a reputable application provider. So we can apply some machine learning to the data that we're collecting. What we then do within the AppDefense system through this learning phase is we start to define our applications. So what is the scope of an application? What are the components of this application? What we then do is we create a manifest. And the manifest is very akin to a birth certificate. So for a given application, we will have a manifest or birth certificate, and that manifest will capture all of the intended states for this application. So this application is comprised of these workloads, it's comprised of these processes are communicating to one another on these ports, using these protocols. So all of that behavior is captured within the manifest. The machine learning is really important for us because it allows us to provide this adaptive whitelisting. So the model that we build within AppDefense is constantly evolving, and it's learning to build better understanding of what behavior should be good and what deviates from trusted or known good behavior. What we are actually doing with every AppDefense implementation is creating this concept of distributed consensus. So if we've got 1,000 customers deploying AppDefense, we have visibility into each of those deployments of AppDefense, and we can feed that visibility into the machine learning. So thereby our machine learning has a high fidelity of information within it, which means that we can provide back to you a really strong, authoritative, and repeatable set of behaviors that we can model against. And this is what allows our system to understand what is legitimate versus actually what isn't legitimate, and what shouldn't be reputable or trusted behavior. So this allows our rule set to adapt and evolve, because we have this very broad data set. So that's how we apply this concept of machine learning within AppDefense. So once we've gone through the learning phase, once we've applied this machine learning, we then move AppDefense into a protect phase. And the protect phase allows us, as it says, to protect a known good state. We're using a couple of components within the AppDefense architecture to achieve this. So we have the manifest. The manifest is stored within the hypervisor, within a protected zone, so it can't be tampered with. And what we then do is we have visibility into the guest or the endpoint that we're protecting that forms part of this manifest. And we get visibility into all of the processes, everything that's running in memory, all of the behaviors associated to those processes. So if there are any deviations to what's contained within the manifest, we will be able to identify those. What we can then do in response to detecting any deviations is think about how we want to respond. So do we want to maybe suspend a workload or snapshot a virtual machine when we detect a deviation? Do we want to maybe go a step further and block or maybe quarantine or isolate at a network level the workload when we detect a deviation? So we can start to think about how we actually want to be proactive with how we manage these deviations. So at a high level, that's how AppDefense functions. As I said, we would initially go into a learn phase where we're capturing all of this behavior, we're analyzing it, we're applying our machine learning to feed back to you whether or not this is trusted behavior or should be trusted behavior, whether it's reputable. Once we've gone through this learn phase, and we can leave AppDefense in the learn phase for as long as you would like, until you're comfortable that what you've captured is all of the application behaviors. We then switch AppDefense into this protect phase. At that point, we're protecting your applications. We've approved what is known good behavior, and we can think about how we then detect those deviations and ultimately respond to those deviations if we see them. So do we want to maybe be passive in what we're doing with AppDefense and maybe just alarming? Or do we want to go a step further and be active in our responses and maybe block those things from happening? Now, clearly, applications will evolve over time. And this is where we need to be able to deal with change ultimately. And we can use data center orchestration systems, provisioning systems to update these manifests. Using this process that we see here of continuous learning and continuous protection. So we can hook into provisioning systems. So if you're deploying a new application version that's maybe using different executables of a newer version, maybe those executables operate in a slightly different way. They communicate with different components of the application using different protocols, using different ports. We can take a feed from provisioning systems to update our whitelist. So ultimately, the whitelist is reflective of any application state changes over time. Thus, what this means is that the model of zero trust that we achieve in AppDefense isn't a static model, it's a constantly evolving model. So I've spoken a lot about AppDefense and this concept of least privilege at an application level. Least privilege at a network level is something that we've spoken about for quite some time within a network level. So being able to create a network security model of least privilege or zero trust, such that the policies that we create at a network level follow a whitelist security model. So everything is blocked by default, and we are whitelisting what we want to observe. And we achieve that using NSX. NSX has a distributed firewall, which is running in front of each individual endpoint. It gives us full visibility into traffic flow at a network level, both ingress and egress. And I've been talking during the session about AppDefense, which extends that concept of least privilege to a compute level. Where we would like to go in the future is to use the visibility that's provided in AppDefense to drive the network security model at an NSX level. So AppDefense has that visibility into what processes are initiating network connections and communications with other endpoints in the data center, given it hooks into provisioning systems to understand how those applications are changing over time. When it sees application behavior changes, what we would like to be able to do is to feed that data into NSX as part of a closed loop to update the network security policy. So this is where we want to go in the future, and this is what we're calling adaptive microsegmentation. So AppDefense can drive your network security model in NSX as well. Okay, so I'm conscious that I've covered this at a high level of detail, but I think clearly there's a lot of detail that sits behind this. And there's some really good sources of information to dive into the detail around this. So I would draw your attention specifically to the right-hand side of this slide and point you to some of the communities that are available where you can find more information on AppDefense. We've got a really strong community around AppDefense. So I would, in the first instance, point you to communities.vmware.com and to step into the AppDefense community. We then have this portal that we refer to as the NSX mindset, which is really, it's focused around NSX, but I think it's as applicable to AppDefense as well. And it talks you through how these technologies can change the organizational models within traditional enterprise IT, and it really helps you with what that should look like and how best to tackle some of that organizational change. And then the last point of really strong deep collateral on AppDefense and NSX is the network virtualization blog that you can see on the bottom right-hand corner. And is the case with all of the VMware technologies, we also have the VMware Hands-On Lab, where we have free-to-access labs, and that's accessible through labs.hol.vmware.com. And as I said, that's free-to-access lab environment. So if you want to get some hands-on experience with AppDefense, we also have a hands-on lab where you can do that. So if you've got any questions or comments, I'm going to hang around after this recording to go through any of those questions, and I will also go through any questions raised on the Q&A. So thank you very much for joining. I hope that's been useful. As I said, if you've got any questions, I'll do my best to answer those now. Thank you.